Hello everyone, welcome to another video. In this video, we're going to talk about the rate of reaction questions, which are usually tested in paper 4. Okay, this constitutes a very important part of P4, the rate part. There's hardly any paper, whether it's the IGCSE pattern or the CI pattern, there's hardly any paper which do not have anything related to rate. So rate of reaction is a very major chapter as far as paper 4 is concerned. So, hydrogen peroxide reacts with iodide ions to produce water and iodine. The initial mixture is colorless. Now, iodine is being formed. So, what is observed during this reaction? So, obviously, solution turns brown because iodine is being formed. So, solution turns brown. After that, the rate of this reaction is investigated by removing samples of the reaction mixture of equal volumes at timed intervals. So basically, samples are being removed after every, let's say, 100 seconds. The sample sample is being removed, and in each sample, calcium carbonate is added in the flask to stop the reaction. Just why the reaction stops when the sample is added to calcium carbonate. So calcium carbonate will react with the acid. Yeah, calcium carbonate will react with the acid. The acid. Calcium carbonate neutralizes the acid. So just why the calcium carbonate is powdered. Powdered means it will have a greater surface area, so higher rate of reaction. It's powdered to increase the rate of reaction. Which is powdered to increase the rate of reaction. Okay, and the third part state what is observed when a sample of reaction mixture is added to calcium carbonate. Whenever there's a carbonate involved and they're asking about the observation, you should know that carbon dioxide is going to be released and the observation is going to be effervescence or bubbling. But you should know that this can only be seen if it's a solution of liquid, because bubbling can only be seen when there's a liquid. Okay. So after each sample is added to calcium carbonate, the content of this flask is titrated against sodium thiosulfate. Okay. The sodium thiosulfate reacts with the iodine that is being formed, which means that as the reaction is progressing, more and more iodine was being formed. Now, if you look at this reaction, as the time is progressing, more and more iodine was being formed. So the samples that are taken, after a while will have more iodine. So they are going to react with more sodium thiosulfate. So volume of sodium thiosulfate needed for each titration depends on the amount of iodine in the sample. So more the iodine, more will be the amount of thiosulfate required. So at 0, volume of aqueous sodium thiosulfate needed for titration was 0. After 100 seconds, there was a certain amount of iodine that was produced, which was reacted with sodium thiosulfate. 11 centimeter cube of sodium thiosulfate was needed. And after 200 seconds, 12 centimeter cube of sodium thiosulfate was needed. As you can see, as time is progressing, more and more sodium thiosulfate was needed because more iodine is being formed after. But at 500, 600, the volume is constant, which means that no more iodine is being formed. So let's plot this on the graph. So I have plotted the points at 0. The volume needed was 0. So plotted a point here. At 100 it was 11. At 200 it was 12 and 15.5 and so on. I think plotting part is pretty easy. I don't think you guys will have much problem with it. Right? Okay. So let's draw the curve. This would be, obviously you guys will be needing a scale or something. I'm not doing it so well. Just wait a second. So it's basically a classic rate of reaction curve. A volume like something like this, right? Okay, so draw a circle around the anomalous point on the grid. So this is going to be the anomalous point because it's not following the overall trend. Use the points to draw a curve of best fit. I just did that. Use the graph to determine the volume of thiosulfate needed for a sample taken at 250 seconds. So for 250 seconds, this would be somewhere, somewhere here, and you'll have to draw the dotted line here. यहाँ से आप निकालेंगे basically the volume. So draw the horizontal line from here, Okay, it will be touching somewhere here. There will be a slight difference in my values because I'm doing it digitally, but I'll write the correct one so that you guys know कि आपकी क्या आनी चाहिए value यहाँ पे. This would be 13.5 centimeter cube. Okay, this would be 13.5 centimeter cube, but the method is the same. 13.5 centimeter cube. After that, use the graph to determine the time at which sample is taken if 6 centimeter cube of sodium thiosulfate is needed. So in this case, you have to go in reverse. Y-axis is the volume thing. So 6 centimeter cube would be somewhere here, right? And you will drop it down. So this would come at 80 seconds. Okay? Okay, so let's move on. Describe and explain the difference in the slope of your curve. Seconds. Okay. As the time is progressing, basically the rate will be decreasing, the slope will be decreasing, the graph will becomes horizontal slowly. Okay, so what will be the difference in slope? The slope is going to decrease. Slope decreases, which means that as rate decreases, rate of reaction decreases. And what will be the explanation for this? Explanation is simple, as because concentration of reactants are basically decreasing. So explanation would be that concentration decreases, because obviously whenever there's a rate question, you'll have to talk about effective collisions, right? So as concentration decreases, leading to less successful collisions, less successful collisions. Okay, so let's move to question number 2. It's the very famous reaction. Calcium carbonate is reacting with HCl. So let's get to the part of the question. So what is meant by an excess of calcium carbonate? Excess means more than what is needed. Okay, so excess means more than required or more than needed. Okay, and what does excessive calcium carbonate mean? That the calcium carbonate is more than needed, okay, to react with HCl. So name two pieces of apparatus A and B. A is pretty much simple. A is conical flask and B is gas syringe. So A is conical flask and B is gas syringe. Conical flask and gas syringe. Okay, the student does experiment 1 at 20 degrees Celsius. Okay, experiment 1 is being done at 20 degrees Celsius. Name a piece of apparatus that can be used to keep the temperature constant. If you want to keep the temperature constant, you have to make sure that you're using a water bath. But not just a simple water bath, you'll be using a thermostatically controlled water bath. Thermostatically controlled water bath. Right? Okay. So the next part is the student does two more experiments. He did the first experiment and then he did the second experiment at experiment 2 at 40. So basically he's increasing the temperature. He did the experiment 3 at 60 degrees Celsius. So suggest two variables that a student keeps constant, so the temperature is the only variable that affects the rate of reaction. Whenever there's a solid involved, just make sure you're adding the equal mass. But if you're adding an excess, so then the mass does not matter. Then you have to focus on the surface area, that the particle size has to be the same. Okay, you have to make sure that particle size have to be kept constant. So particle size will be the one thing, and there's a liquid involved, so you have to make sure that the concentration of the acid has to be kept constant. Concentration of the acid. Okay, if you're confused about the excess part, now just make sure that if the solid is in excess, just make sure if there is a solid involved, we can talk about particle size, and whenever there's a liquid involved, you can keep concentration of the acid constant. And then it won't matter that whether acid is in excess or salt is in excess. Okay, because अगर liquid excess में ना, then you cannot take its volume. अगर आप solid excess में, then you cannot take its mass. Just remember, particle size is applicable to all type of questions, and concentration of acid is applicable to all kinds of questions that has liquid being involved. Okay, now student plots a graph of the results. You have 3 experiments. So the fastest will be the one with at the highest temperature. So this leftmost curve is going to be the third one. Rightmost curve is going to be the 1, and then this is going to be 2. So describe how the graphs are used to decide which experiment has the fastest rate. The one with the greatest gradient or the steepest gradient will have the fastest rate. The graph with the steepest gradient, will have highest rate. How the graph shows that the reactions stop. So the graphs become horizontal. So graph becomes horizontal, or it levels off. Graphs become horizontal. Now, why do the reactions stop? Often student answer this as, why do reactions stop? Because reaction is finished. अरे भाई, इसका मतलब दोनों का सेम ही होता है. Why do reactions stop? Because reactants are consumed. But you cannot say just reactant. You have to say, you cannot use the excess reactant in this answer. You cannot say the generic that reactants are consumed. You have to make sure that you use a reactant which is not in excess. For example, we know that calcium carbonate is in excess here. So you will not use calcium carbonate. You will say that, why do the reactions stop? Because all hydrochloric acid has reacted. Okay. Okay, so the next question is a planning type question. I've done a separate video on planning type questions. There are around 17 questions in which I've discussed different types of planning questions that usually are tested in exams, but we're just going to go through it quickly. So basically, we are planning an experiment in which we are adding calcium carbonate to HCl, and carbon dioxide gas is being released, and we need to formulate an answer which includes a method, the measurements you need to take, and how will you process your results. Okay, we are going to collect the carbon dioxide gas. So basically, first of all, you have to mix calcium carbonate with hydrochloric acid. You're not comparing or anything, you're just simply collecting the carbon dioxide gas. You have to just write the steps for this. You may use a label diagram. You can or you can't. It's your call. You may or you may not. It's your call. Okay, they're not asking you to do it. Like, definitely, you don't have to mandatorily do it. So let's mix it. So mix calcium carbonate with hydrochloric acid. Just tell them that where will you mix them. Mix calcium carbonate with hydrochloric acid. Usually you see that happening in a conical flask. And you have to make sure that the apparatus is airtight. So that no gas can escape. So that no gas or carbon dioxide can escape. Okay. Then mention that you will attach the conical flask. Attach the gas syringe to the conical flask, where you will collect the volume of carbon dioxide gas. So attach the gas syringe to conical flask to measure volume of carbon dioxide, okay, and use the stopwatch to measure the time taken for all gas to collect. Okay, so I think that would be enough. You can also say, because we have to calculate the rate, you'll have to say that rate will be calculated. Rate of reaction will be calculated by dividing the total volume of gas by dividing total volume collected by time. Okay, so this would be your answer. Okay, so in question number 4, there's obviously a gas is being collected over water. So basically what's happening is, in the presence of a catalyst, hydrogen peroxide decomposes into water and oxygen. A student uses the apparatus as shown to investigate the rate of decomposition of samples of hydrogen peroxide at 2 different temperatures. The experiment starts when the flask is tipped. This flask is tipped, which means it must be connected to a thread, and that thread was pulled. So the contents of this little flask was actually put into the conical flask. So the oxygen gas is collected in the measuring cylinder. So O2 is going here. What property of oxygen gas allows it to be collected by this method? If it's being collected over water, it means that this is insoluble in water. It means that the oxygen gas is insoluble in water. Name an alternative piece of apparatus that could be used to collect and measure the volume of a gas. You can simply collect it using a gas syringe. Okay. Give a test and observation to identify oxygen gas. We all know that for oxygen gas we use a glowing splint. The test is using a glowing splint, right? And the observation is, when you expose a glowing splint in front of oxygen, the glowing splint relights. Okay, you have to make sure that you write the test and observation correctly. A lot of students just simply say glowing splint relights. They don't know which part is the test and which part is the observation. So understand, the test part is the glowing splint and the observation part is that it relights. So now against time they have plotted the volume of gas that is collected. Okay, and I've already plotted these points here. Since plotting must not be a problem, okay. So let's draw a circle around the anomalous point. You can already see this anomalous point here. Use the points to draw a curve of best fit. So it is a curve, it's not a straight line. We know curve is something. Volume की curve इस तरह की होती है. It becomes horizontal. The student repeats the experiment at 50 degrees Celsius. Draw the second curve on the grid to represent the results that are obtained at this higher temperature. At higher temperature, the curve is going to be a bit steeper. So it will go like this, and it will go flat earlier. Yeah, you have to show that it has gone flat. I'm just going a bit upwards. The best way is to just flatten it here. Like this is the 100, this is 100, now यहाँ पे flat हो रही. Okay, now just connect this to here. Okay. Yeah. Then connect it with this. Okay. So difficult to draw these graphs digitally. Okay, so explain your answer. What is going to happen? The gradient is going to be steeper. Okay, we'll have to explain this. How much mark is it carrying? Okay, this is carrying 4 marks, so you have to explain it properly. The curve is going to start at the same point, right? So second curve start at 0, 0, which means the origin, and is steeper but it becomes horizontal at the same height okay. You have to explain your answer as well, that why is it happening. So it levels off at horizontal at the same height a bit earlier, which shows greater rate at higher temperature. Okay, basically, if you compose it, I needed to compose it a bit more in a more structured manner. So you can compose it like this. While I was writing this, it was getting composed in my head in a better way. So you can say that second curve started this and is steeper. Why is it steeper? Because rate is higher at higher temperature. Okay, that will be your 2 marks. Okay, then you can say then it becomes horizontal first, but at the same height, because same volume of gas is being produced. Okay, so structure it like this instead of like this. I just wrote it too much. So I've explained it. Hopefully आप लोग ये कर लेंगे. But the point that I missed actually was that since it is gaining the same height, it means that same volume of gas is being produced. Because this curve has actually two parts. The first thing is it is steeper, and the second thing is that it's getting horizontal at the same point as the previous curve. So you have to explain both of these dynamics. Okay, so let's move on. So we have question number 5 again. We are decomposing hydrogen peroxide and oxygen is being released. Now student uses the apparatus shown below to investigate how the rate of decomposition changes while using two different catalysts. Okay. The student does 2 experiments using the same volume and concentration of hydrogen peroxide, but with the same mass or different catalyst in each experiment. Okay. The manganese oxide is added to the hydrogen peroxide solution and the mass of the flask and contents recorded after 30 seconds. So this is experiment 1. Why does the mass of the flask and contents decrease during this reaction? This is loss in mass wala method. So the mass of the flask is decreasing because oxygen is leaving the flask, because gas is leaving the flask. So you can say it's decreasing because gas is escaping. Or you can also name the gas oxygen. Give 2 reasons for using the loosely fitted cotton wool plug. One of it is that when oxygen molecules will move through this cotton wool, there is a risk that when oxygen bubbles out of the solution, it may carry some droplets of liquid. Okay, so we have to stop that. And why is it loosely fitted? So that the gas can be allowed to go out. So what will be the reason 1? Reason 1 will be to allow the gas. First of all, it's a cotton wool so that gas can be escaped, to allow the gas to escape. And we use the cotton wool because we didn't want liquid to escape. So we don't want, the reason 2 would be so that liquid does not splash out. Okay, so the next part is that the experiment is repeated using the catalyst copper 2 oxide instead of manganese 4 oxide. All the experimental conditions are the same. This is experiment number 2. So experiment 1, they're given you the time and the mass of flask. Then you can actually compare the 2 experiments. For example, after 30 seconds, the mass remaining in experiment 1 was 89.63 and the mass remains in experiment 2 is 89.71. So experiment one is actually taking place a bit faster as compared to experiment 2. Okay, so I have plotted the points. Experiment 1 is in blue and experiment 2 is in red. So this I'm connecting these. Right, they're ending at the same point obviously because same amounts of reactants are being used. And you have blue. Mhm. There will be slight errors when I'm making the graph. I keep on saying this, I know, but you should be aware of it. Now, what are they looking for? Use your graphs to answer the following questions. What is the total loss in mass in experiment 1 after 45 seconds? So let's check. In experiment 1 is in blue. Right after 45 seconds. 45 seconds would be right between 30 and 60. So 30 and 60 will be here, and you'll have to check. So this is the line, which means this is the line. So it is 89.51, 52, 53, 54, and 55. So 90 minus 89.55 actually. And let me check the correct answer as well, because mine may have some issues. To solve this better, it's 0.08, and yeah, it's 89.55. It is for 0.46. The answer is 0.46. That's how you calculate. Okay, so 0.46. Yeah. Okay, so how much greater is the loss in mass after 75 seconds in experiment 1 rather than in experiment 2? Okay, and you have to show your working. So we have to show your subtraction. So experiment after 75 seconds. Now let's see after 75 seconds. 75 would be right between 60 and 95 here. Right, so this is the line which is edging at here. This is for experiment 1, and if I just extend this line for experiment 2 as well, the line is this one here. This is 89.66 and sorry, 89.55 के करीब है, and this one is 89.47. Okay, so you'll have to show the working here. We'll subtract the values. I'm writing the actual values, not what I have calculated. There might be a slight difference. I'm just writing the exact values from the marking scheme so that you guys know what your answer should come from this. So this is 0.08. Okay. So which of the catalysts is more effective? Use your graphs to explain your answer. So we know that experiment 1 where manganese oxide was being used, that is actually the rate is more there. So that's what you will say, that manganese oxide is better as the graph is steeper. As the graph is steeper. Why are the last two masses in the table the same in experiment 1? Because all the hydrogen peroxide is reacted, so no more oxygen is being released. All the hydrogen peroxide has reacted, right? Now predict what the mass of the flask and contents would have been if experiment 2 had been carried out for another 30 seconds. So you'll simply extend it. Okay, Balki, you don't even have to extend it. You know that mass is not changing anymore. All the hydrogen peroxide has actually been used. So it's going to be exactly the same as it was 30 seconds before. So the answer would be 89.45 because that was the mass when all the gas was collected. Okay, so I've incorporated this question just for a few parts because the rest of them are pretty much the same. So I'm not going to discuss the parts that we have already done before. This is again hydrogen peroxide. It asks you to suggest 2 safety precautions the student should take to minimize the risk from using aqueous hydrogen peroxide. And he has told you that it is an irritant to eyes and skin, so you'll have to uh, take precautions accordingly. For example, for skin, you should be using protective gloves, and for eyes, you should be using safety goggles or just goggles. Give one reason for using the loosely fitting cotton wool plug. We have already done that. Which two measurements you need to take in order to follow the rate of reaction? You need to measure the loss in mass and time, right? And then again, you'll have to plot the graph and all of that stuff. You need to draw a diagram the student uses to achieve the results in the table. Label the apparatus that is used to collect and measure the volume of gas. You'll have to draw the apparatus which has gas syringe on it, right? You'll have to draw that. That's airtight, gas syringe on it, okay? And also draw the stopwatch, and you need to label all these things that this is gas syringe, this is conical flask, and this is stopwatch, okay? You need to plot the graph like we already did. Use the curve to determine the volume of oxygen produced in the first 50 seconds, the second 50 seconds. I think you guys will be able to do this. It's not much of a problem here. So you need to understand one thing, that this is not just rate of reaction. This is also an objective. Basically, you know that there is an objective called observation where you'll have to read the readings, or you have to talk about the color changes. That's tested in P4. The second objective is what we did was planning, whose video is already uploaded. Okay, and then there is something called interpretation. Interpretation is basically plotting and extracting information from the graph. So this particular video actually covers both the rate of reaction and the graphical part of the P4. Okay, and the last one is actually evaluation, which actually whose parts keep on appearing in different types of questions. Evaluation is basically that what can you do to improve an experiment. For example, you were measuring 25 centimeter cube of a liquid, and you were using measuring cylinder to do that. So he'll ask you what improvement can you make to this experiment. You will say that okay, you can use a pipette or a burette. So stuff like that. So this covers a lot of stuff, not just one chapter. Okay. So see you in the next video.